Hi guys, welcome back to this channel. In this video, we'll be going over combination sum 3. This is problem 216 on LeetCode. I think it's a pretty interesting problem. It introduces us into some concepts like recursion, sets, dealing with duplicates, stuff like that. So yeah, we'll just get into this problem. So the problem says find all combinations of k numbers that sum up to n such that the following conditions are true. Only numbers 1 through 9 are used, and each number is used at most once. Return a list of all possible valid combinations. This list must not include the same combination twice, and the combinations may be returned in any order. So, let's take a look at an example. So, in this input, we are given k, which is 3, and n, which is 7, right? So that means what we're going to output is a list of lists, and in this case, there's only one possible combination. It's 1, 2, and 3. So, So if we phrase this in terms of the input format that we're given, this means that there are three numbers, like we have to use three numbers, and they have to add up to 7. So 1, 2, and 4. There's no other valid combinations. Now let's check out example 2. This one, k is again 3, but n is this time 9. So this means we again need three numbers, and they have to sum up to 9. So here there's a lot more combinations. There's 1, 2, and 6. There's 1, 3, and 5. There's 2, 3, and 4. So one thing that we should notice is, yes, 1 is used multiple times, but these are in different combinations. So this still fits under the problem. The last case is kind of like a base case in a sense. So this time it's saying use 4 numbers to add up to 1. Now let's remember that only numbers 1 through 9 are used. So this isn't actually possible. So in this case, you'll just output a blank list. So let's get into the approach for this problem. So here what we're going to be doing is we are going to be using recursion to tackle smaller chunks of the problem at a time. Let's take the first example. We can see it right here. And here k is equal to 3, n is equal to 7, and now we are trying to find all the different combinations. So as a simple base case, what we can think of is, how do we know if we're done? We know if we're done is if n is equal to the total, right? Whatever total that is, right? Like that's just a variable name. And if k is equal to just some given amount of used numbers. So k is equal to given used numbers. That's kind of a long variable name, so we'll probably change that in the code, but that should be fine for now. So now let's look at what to do. So this is the base case for how do we know if this combination works. That's how we know if the combination works. Now let's check, how do we know if the combination doesn't work? In this case, suppose the total is greater than n, right? The total, if it's greater than n, that doesn't work. Another case would be what if the total number of numbers that we're using is greater than k? That's another way we can tell it doesn't work. Or what if we've gone on beyond the allowed numbers? So suppose we're using an index to track the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, right? What if this index goes beyond 9? Then we also know it doesn't work. So if the index goes beyond 9, it doesn't work. A cool thing about using an index in this problem is that the index actually matches up to the value of the number, right? 1 maps to 1, 2 maps to 2, etc. So now let's actually get into the recursion. How will this recursion work? So every time we call the function using a new index or a new number, there's one case that we have to consider. There's two cases that we have to consider. Do we want to include this number or not? So suppose we're calling some helper function, right? The question is, do I want to include, or let's take this example, right? 1, 2, and 4. When I get to 3, do I want to include 3 or do I not want to include 3, right? So what we'll be doing actually is we'll be taking care of both cases. In one variation, we'll include 3. Now, supposing we do include 3, it'll fall into our check over here, where the total will be greater than n, or it's just too many numbers. Now, suppose we don't use 3, right? We just move on. Now we use 4 instead, right? And that works out perfectly for us, because eventually, after considering all the different cases, n will be equal to the total, right? So now let's get into the actual code. Okay, so for now, I'm just going to put this as pass, and let's implement a helper function. So in this helper function, what we have to remember is that we only want to change the result in place. We don't want to be returning a new result. Why do we want to do this? Is because it makes our implementation of including numbers and not including numbers easier. So let's pass self, let's pass k, let's pass n. Now, what we're gonna add is a new argument here called index. What the index will do, the index will handle if we want what number we're currently on. So as we progress through 1, 2, etc., it'll keep track of what number we're currently on. Now, if we remember our base case, let's include a total. This is the total sum, right? And let's include a result, obviously, because that's what we're changing in place. And let's also include like a current string, or like the current amount of numbers that we're working with. We can call this current t, current string. Doesn't really make a difference. This will all get a little bit like clearer in the code because it's easier to see than explain. But let's just set current length equal to the length of current s, or current string, right? So what this is doing is just like having a variable that will change on every call, and we can measure it with some other stuff. So now let's go back to our base cases, right? If n is equal to the total, and current length is equal to k, right? Then, oh yeah, we can now add this to res, right? So we can do res.add tuple of cur s, right? So what this is doing is we're checking if the current numbers that we're working with, if those work out, then yeah, we can add it to result. And remember, we're not changing result. We're not adding a new result. We're just changing the result in place. So now let's go to our other base case. How do we know if it's not going to work? So if total is greater than n, or current length is greater than k, or index is greater than 9. Remember, this is just checking out all 3 different possible cases of how it won't work. So now we're just returning blank. We're just moving on, basically, but we're not excluding the test case. So now let's get into this recursion. This is actually like a really beautiful part to see. So the logic for implementing for inclusion and exclusion is kind of cool. So what we're going to do is we're going to do total plus index, right? So we're updating the total value with the index. And now what we're going to do is we're going to take this current number that we're working, this current index, current number. What we're going to do is we're going to append it to the current string that we're working with, right? From there, we will now call our helper function. We do self.helper kn. Here, we will now update the index. So now we're using an even smaller set of numbers, right? Well, actually, technically just a new number. We're not using a smaller set of numbers, but eventually it progresses to like no more numbers. A total, a current s, and result, and our current s. Right? Now, here's the beauty. What we're going to do is we're just going to remove the index from the total, right? So the total effectively remains unchanged. We are now going to do current s.pop. So now it's not going to touch anything we've done before. It's only going to pop the most recent addition, which is this current index. And then now we're going to call self.helper again. We're going to do k n index plus one more time, total, result, and current s. Now, that's it. That's the entire code. Well, okay, that's not the entire code. That's the entire helper function. Now, let's go and implement this helper function. We will have a result, which is a set. We are using a set because we want to make sure that we don't get any duplicates, right? Like 2, 3, 2, and 3, 2, 2, right? We don't want that. Now we can call self.helper from the beginning. Here we'll pass k, we'll pass n. For the current index, we'll pass 1 because that's the first number that we're working with. For the total, we'll pass 0 because nothing's been added yet. For the result, we'll just pass result. And for the current string, it's just blank. I know I'm saying current string, but it's not really a current string. Um, anyways, so now we come here and we now return list a result. Because remember, the output format is a list, whereas this is a set, so that doesn't really work out. And yeah, that's it. That's the entire code. So let's just run through this really quick. In theory, we're calling this helper function on every possible number. So first 1, then 2, then 3, and then going up all the way up to 9. If the total and the current length are equal to each other, perfect, that works out. If any of these conditions are violated, then oh well, we move on. Now here we're updating the total with the current number, we're updating the current string with the current number, and so this case is including this current number, whereas this case is moving on. It's not dealing with that number. Okay, so let's run this and hopefully this works. Okay, here it's saying current s isn't defined. Oh, that's my mistake. Here it'll just be cur s because that's the name that we gave. Okay, so it's accepted, it's working. Now let's submit. Hopefully this works. Oh wow, okay, so this is really cool. So our runtime was 0 milliseconds and it beat 100% of all the other submissions. So wow, that's really cool. It worked, it's efficient. So yeah, this is great. All right, thank you guys for watching this video. If you want to support the channel, please subscribe. If you have any questions about the code or the logic, please just leave them down in the comments below. I'll be sure to respond to them.